Hey guys, and welcome to the second part of the uFrame tutorial. In this part we're going to take a look at the initial concept and setup, get familiar with the uFrame diagram editor, and finally we'll create elements for our game. So let's start with the concept and setup. As you can see, my project is quite clean. I have imported three packages: uFrame, UnityVS, and standard scripts. UnityVS is not a requirement. It just serves for a better workflow and connection with Visual Studio, which I use. And also I use camera follow script right here from the standard scripts package right here. As you can see, we're going to make some sort of a Space Invaders game. And I've started to learn drawing a few days ago and got myself a little bit familiar with Adobe Illustrator. So here's little ugly art I've prepared just to make things look more alive, you know. And all the art assets, if you can call this art, along with the prefabs, will be available for downloading, and you can do whatever you want with it. By the way, I've also prepared a few prefabs, for example, a platform with the wheel, which is going to be our main character. It has two wheels, we set up physics, it has a gun point, and it has a camera follow object, just to make camera follow a specific point in the space. And it's probably not the best way to organize those kind of things, but for now let's just keep things as clear and as clean as possible. I also got a bullet prefab, or a rocket prefab, if you will. There we go. And I have those enemies here, which are going to attack us, maybe not, we'll see. So this is some sort of a conceptual scene just to mess up with the prefabs, but we're going to start from scratch. So now, when we got familiar with the project and the setup, it's time to design our main game diagram. If you first open the element designer or uFrame diagram designer, you will only see the example diagrams, which are a good source of information, but we're going to start our own deal. So we first need to create a folder which corresponds to our game name, maybe just something that makes sense for you. I'll call this Pinky Aliens. And now we need to create a diagram file. So you can go to uFrame, new element diagram. And you have to name it in some way that makes sense for you too. So I usually stick up with the game name along with the diagram word following after it. Now when you open the element designer, you're going to see it in the list. You can click it and start editing. Before actually designing elements themselves and explaining what the element is, I have to say a few words about the initial setup, which uFrame requires to function properly. So we will talk a bit about the scene manager and the subsystems. As you may remember from the first part of the tutorial, the whole thing is about view models, controllers, and views. In order to make them function properly and work with each other, we need some kind of an object or objects to do all the internal setup. Those objects are called Game Manager and Scene Manager. Game Manager is always the same, and it's not destroyed on scene load. And we can add it directly into the scene right now. And we add up a component called Game Manager. Game Manager manages or sets up scene managers, and Game Manager doesn't require much attention from your side, except maybe that you have to set up a startup scene manager. But your game may have much more than one scene, so you need several scene managers for each scene type. Scene managers set up view models, controllers, and views, wire them up, and do a lot of other things that otherwise you would have to do yourself. So let's create our scene manager. And when creating a scene manager or any other object, you should be quite specific and name it properly, because a class will be generated with the same name. So I will call my scene manager Pinky Alliance Game Scene Manager, which is okay for me. Maybe you can shorten it a bit if you want. But how does Scene Manager know what parts of your project is going to be used in the scene? What kind of entities are going to be managed by this Scene Manager? That's where subsystems kick in. As you divide your game into entities like players and enemies, you can also combine them into logical groups, and such group is called subsystem. So let's create a few. Let's call this game system, and let's create another one called character system, or maybe characters. As you can see, I was much less specific with the name in here. This is because subsystem does not generate any class files for you, so you can be much less specific with what kind of subsystem it is, but the main rule, always name the things that you can understand what's going on later, and also name it so that other people can understand. So now time to wire things up a bit, and now I'm going to tell this Pinky Alliance Game Scene Manager that this is going to work with game system. So I hold my control button and drag this little arrow to the Scene Manager. Now it knows that it's going to work with game system and all the elements which are going to be inside the game system. But what if I have some sort of modular systems? For example, game system relies on character system. In that case, I just drag character system to the game system, and this automatically tells the main Scene Manager that it is going to be used game system along with character system. Simple enough, huh? So now, after I clicked save and compile, I got a few files generated for me. Look at this. This one is very special because it corresponds directly to this Scene Manager on the diagram. Now, as I have said, Game Manager requires a startup Scene Manager to boot with. So we'll create another empty object called Scene Manager. Oops. And we're going to add a component called Pinky Alliance Game Scene Manager. Yes, it's mono behavior, but don't be confused, it's not view at all. So now we can finally wire things up, and look at what's going on. Those are subsystems which are going to have our elements, and now this particular scene knows that it's going to work with exactly those elements because those subsystems are wired to the Scene Manager, which is the startup Scene Manager of the Game Manager in this scene. So now everything is set up and ready to work. But yeah, one could say, oh, I'm lazy, I don't want to set up those things, it takes too long. Okay, you can just go to your Scene Manager and right click on it and click Create Scene. Then you can go to your Pinky Alliance Scenes and give it a name, Game Scene. And guess what? It's exactly the same. So now you know how the scene is set up manually, so you know what's going on. So finally, we're ready to create the elements of our game. But what is an element? For now, you can just consider element as a model of some entity in your game, and you should forget about how your game is going to look like visually and pay attention to models, or better say view models. Think about it for a second. What kind of entities do we have in our game? We have enemy, we have a platform. We also have a rocket, but do we really consider it as an entity? Maybe it's just a view aspect of how characters attack each other, or maybe not. It depends heavily on how you're going to design your game, and as you experiment with different approaches, you will get more confident about such decisions. For now, let's leave the rocket out of the diagram and stick to the enemies and platform. So now, let's navigate to the character system. Right-click on the diagram, add new element. This is the element, and you can select it by either dragging your mouse around it, or you can just click it. If you want to change the name, and you definitely want now, you can press F2 when the element is selected and enter the name you want. For now, let's design the platform element. First, we have to define a few properties for our model. Let those be health, speed, and fire rate. But we want those to be floats, so we can click on particular property and click on its type. A list will pop up and you can select the type you want. Now, as you remember, we also need some commands which we will send to the controller every time a view produces a new event for us. Like, for example, player clicked the button, or player wants to move left or right, or your platform was hit. So let's define those. Let's introduce hit command, or just hit, which we will send every time our platform was hit with an enemy rocket. Next, let's introduce move command, which we're going to send every time our player presses A or D or any other keys you want to be movement keys, you know. But if you think about it for a while, you can see that we bring no information about if we pressed A or D and if we should move left or right. So to fix this, let's introduce an argument for this command. If you click a command, you can see this little known sign here. If you click this, you can select a type which will be a parameter for your command and will travel along with this command from the view to the controller. So we can stick to the Boolean parameter for now, because we can define left as false and right as true. Now let's introduce more commands, like for example fire start, or better start fire, and stop fire. We're going to send those every time player presses fire key or releases fire key, so we can keep firing while player holds the key. And also we need a special command which we're going to send every time our bullet is fired visually, because we need some delay between those attacks. So that's why we have a fire rate property here. So let's introduce a rocket fired command. If you double click the element, you will be in a new inner diagram. In this diagram you can define views. So for example, I can right click on the diagram, add new view, and you can just name it as you wish, but by default it has the element name plus view word after it, and this is the name of the view, the default one. Now if you click Control and drag this little arrow to the view, they will be wired with each other. For now you just don't care about what these things are, but this thing represents your view. And now if you hit save and compile, you can see the miracles. First, we got a lot of files generated. We got a controller for our platform. We got view model for our platform. We got view for our platform. And this is amazing because you spent like a few minutes designing this, but you already got set of all the classes you want to start working with it, with the logic, with the views, with everything. Now let's design enemy entity really quick. I'm going to introduce only one property, is alive. Actually, let's name it is dead. And I'm also going to introduce a couple of commands, which are hit, and I'm going to send this every time our player actually hits the enemy with the rocket. And I'm also going to introduce earth reached command, which means that our enemy has actually reached the player and the game is lost. And also let's generate default view for the enemy element, like this. Now we can save and compile and see a new set of classes generated for us. So those enemy guys are just going to float in the air, moving back and forth and slightly going down with each iteration, and die every time we hit them, of course. So we need some sort of a view model which will contain information about current game flow, like for example how many enemies do we want on the battlefield, or what's the player score. So let's go to character system, game system, and create a new element here called Pinky Aliens game. And let's define a few properties here, like for example enemy rows, enemy columns, and enemies go down timer. Let's choose appropriate types. So this timer basically defines how long does it take them to make a step further to the ground. And also let's do a score property here. Now, as we probably will have only one player in the game, we can also define a player property. And now, since those subsystems are wired, we can use all those types in this diagram. We just need to right click, show item, and platform. As I have already said, platform represents the player, so we can hold Control on this player property and drag a little arrow to the platform. So now you can see how the type has changed. And now you can see a new type of relation, a view model, which contains a view model as its property. But we are probably going to have a lot of enemies, so we need a collection. First, let's show our enemies right here. Now let's create a collection, rename it to enemies, and finally, holding the Control key, let's drag the arrow to the enemy. So now you can see that we have a collection of enemies in this view model. And it's another type of relationship, you know, when you have a lot of view models in a single view model. So now, as you can see, we got some files generated for us again, like for example a controller for our game view model and the view model itself, but the problem is we got no view generated, and the real problem is that we can't use it in the scene without actual view, so our view model will be useless. So let's generate a default view for the Pink Aliens game. Hit save and compile. So now we have this fixed. So now we got a diagram generated for our game, but you can consider it as a sketch for your drawing if you were about to draw a picture, because your requirements can change over time, or maybe you will find out that this setup is not perfect for your game. So don't be afraid to experiment, because while experimenting you can understand what works and what doesn't. So let's see how we can modify the existing diagram. If we add a new property, we can always change its name even if we have already saved and compiled the diagram. And we can also change the types. So don't be afraid to do this, but always remember you will probably have to modify your working files a bit, and we will talk about it in the later parts of the tutorial. And the same thing with the commands and collections. You can modify them as you wish while your work is in progress. You can also modify elements names and subsystems names. Finally, you can remove the wirings from the object. You always choose the object which is a target of the wire with this little arrow here. If you right click on it, you can see remove link from context menu. And here you can see a list of all the wirings which are bound to the subject. This one corresponds to this platform player on the Pinky Aliens game element. So if we click this, the wire will be removed. And now you can see that player is of type string. Now let's look at a little bug in this version of uFrame. If you fire those again and hit save and compile, you can see an argument cannot be null exception here. This will hopefully be fixed in the later versions of uFrame, but for now we can fix this by hitting play button and hitting this again. Now if we go to elements and click save and compile, we can see that no errors were generated, and also we can see that 0 refactors were applied, because if you look more attentively, we have nothing changed from the previous version of the diagram. And now a little bit of bonus information as always. This is something that I should have told but I didn't in the main part of the tutorial. So a few words about the navigation. When you want to leave the current diagram part, you can just click on this element you're currently in or a subsystem you're currently in. So if I click the game system, I will find myself in the original diagram, which is the sort of a root in your diagram. You can also use those little buttons here to navigate. They correspond to the current path of your diagram. If you want to customize your editor a little bit, you can use this settings button over here to set up colors for the main elements of your diagram. And by elements, I mean every single part of the diagram, like wires, grid lines, elements, scene managers, subsystems, everything. And you can also set up a few other things here, like for example generate default bindings, which we're going to talk about later. And also you can set up a generator path strategy over here. This is something that is going to be useful when you have really a lot of subsystems and a lot of files. So originally, with the default path strategy, your files are going to be stored in the corresponding folders, which kind of tell you what the type of the class it is, if it is a view model or a controller or a view. But if you change it to the by subsystem path strategy, it is going to go ahead and sort this for you in the corresponding subsystem folders, but the type folders will still be there, so you can navigate easily in your Unity editor. But of course uFrame is very young, so a few bugs are included as well. If you look closely, we have this little game system, but for some reason we got enemy view model here, and we also have all the views here, while we have no views in the character system. But if we navigate to the platform, for example, we have a view here. So this is hopefully will be fixed too. For now, if you accidentally switched to the bypass by subsystem and you got those problems, you can switch to default again. And now you will still have all those folders, but they will be empty. Oh, really? They're not. Well, yeah. You can still move those, manually. So let's move those to the controllers and move the view models to the view models folder. Yeah, now they're empty and you can safely delete those. So be careful. If you're going to develop a simple project, default path strategy will be enough for you. If we hit save and compile, we see that 0 refactors were applied. So this is a good sign. We know exactly that nothing was broken. And let's look at another feature that makes keep your diagrams clear. you still have all those enemies and platforms in the character system. So what's the reason for having them here if we can just right-click those and hide those? But notice how wirings were not broken. We still have a player of platform type and enemies of enemy type. So those are now in the correct character systems. And the game system looks more clear now. And speaking about problems you may face with while editing, let me show you a few tips and tricks about the wiring things. So if you add a new element, for example a gun element, just for the sake of example, and add a property, if you just hold Control and wire an enemy to the gun, you can see that now the gun has this little enemy sign here, which means inheritance. And you can also understand this is inheritance because this button is green, or whatever color you set in the settings. Inheritance link color is green. So this is not something that you want when you wire the types. To fix this, you can remove link from the enemy and instead click on the property with the holding Control button. So now you can see this is a type of gun and things are wired properly. You can also experience some, problem if you already have this property like selected. If you click this once and you try to hold Control and wire this, so you will see no arrow going out of this. To fix this, just click somewhere else so you have this property deselected and try again holding the Control button. So yeah, I think that's all that I wanted to show you guys, and thanks for watching, and I'll see you in the next tutorial where we're going to take a look at what files are generated for us, and we're going to explore the code of the uFrame a bit, so you will know a lot of interesting things.